Hello, this is Dr. Moore, and this video concerns stratospheric ozone destruction. Ozone is a compound made of 3 oxygen atoms bonded together. That's what makes it O3. The effect of ozone on living things depends on where the ozone is located. As the saying goes, ozone is good up high, but bad nearby. In the troposphere, ozone is considered a pollutant because of its negative effects on health and the environment. Tropospheric ozone is called bad ozone because it's the major component of photochemical smog. It irritates the respiratory system, it irritates the eyes, it damages plant tissue, it inhibits photosynthesis, and it stresses plants. But the same chemical, ozone, in the stratosphere is essential for life on Earth. In the stratosphere, ozone absorbs high-energy ultraviolet, or UV, rays. UV rays damage DNA and cause mutations. In humans, exposure to UV rays is associated with skin cancer and cataracts. So ozone in the stratosphere is a good thing because it prevents UV rays from reaching Earth's surface where they would hurt human health. In the 1970s, 1980s, it was discovered that stratospheric ozone was disappearing. All over the world, concentrations of stratospheric ozone were declining. In particular, ozone concentrations were very low above Antarctica in September. This is what people are referring to when they talk about the hole in the ozone layer. It's not really a hole, it's just an area of really, really, really low ozone concentration. Chlorofluorocarbons, or CFCs, were the culprit. CFCs are synthetic chemicals that are used as aerosol propellants and as coolants in refrigerators and air conditioners. Specifically, the chlorine atoms from CFCs were destroying ozone. As the name suggests, chlorofluorocarbons are made out of chlorine, fluorine, and carbon. UV radiation in the stratosphere would cause the chlorine atoms to break off from the rest of the molecule. And that chlorine atom would catalyze the destruction of about 100,000 molecules of ozone. And so the global community agreed to phase out the use of CFCs. This was the Montreal Protocol, which went into effect in 1989. And it worked. Production of ozone-depleting CFCs plummeted around the world. And while the CFCs already in the atmosphere continued to eat away at the stratospheric ozone for another 20 years or so, ozone levels are now no longer decreasing. Instead, ozone is being regenerated by natural chemical reactions in the Earth's atmosphere, and we should be back almost to where we started by the end of this century. The Montreal Protocol is one of the biggest environmental success stories. It shows us that the international community can come together and address global problems. But what's this? An asterisk? Let's see what that's all about. Oh yeah, the chemicals we've used to replace CFCs, hydrofluorocarbons or HFCs, are potent greenhouse gases with global warming potential 1,000 to 9,000 times greater than carbon dioxide. So we solved one problem, the depletion of stratospheric ozone, but we're facing another one, climate change. I don't want that to bum you out. That's just the way it goes. When CFCs were first invented in the 1920s, they were considered miraculous because they were non-toxic and non-flammable, and people were happy to have refrigerators that didn't catch on fire. 50 years later, we found out that CFCs were destroying the ozone that protects us from UV rays. So we phased out CFCs, but their replacement happens to exacerbate the biggest environmental problem confronting our generations, climate change. And so it's up to us to do our best to solve the problem that's before us. And that concludes my video on stratospheric ozone depletion.